Hi, in today's video, we're going to talk about turning an alcohol into a leaving group that's not a halogen. And so previously, we had seen that we can convert an alcohol to something like an alkyl bromide or alkyl chloride. So in this case, I'm showing the alkyl bromide with phosphorus tribromide. And this results in an inversion of stereochemistry. This is now a good substrate for SN2 chemistry. So if we have a good nucleophile like sodium cyanide, so the cyanide acts as a nucleophile, this results in an inversion of that stereocenter. In reality, so what we've done is we've inverted that original alcohol stereocenter twice. We've inverted it once via an SN2 mechanism to give this alkyl bromide, and then we've inverted it a second time to give the cyanide. So let's look at a scenario where we only want to invert that alcohol center once. So you can use the alcohol as a nucleophile, and this will react with something called tosyl chloride and form a tosylate, OTS. This tosylate is now a good leaving group. And so if this undergoes an SN2 reaction, it's going to have a net inversion from that starting alcohol. So this starting alcohol starts coming out at us, and this resulting cyanide is coming away from us, or this nitrile functional group is going away from us. Let's look at the mechanism of how this happens. Actually, before doing that, I want to point out that one thing to keep track of is this oxygen atom. So in the top case, the oxygen of the alcohol is gone in the very first step. In the second case, it's the oxygen atom of this tosylate that is part of the leaving group. So it leaves in that second step. So let's look at the mechanism. So in the case of the mechanism, I'm going to show you the full chemical structure of a tosylate. So this is the TS. You're allowed to abbreviate it in the future, and I'll show you what that looks like mechanistically as well. So the alcohol is going to act as a nucleophile. So this is very similar to thionyl chloride and PBr3. So the oxygen reacts with the sulfur, forms a bond to the sulfur, and it kicks off chloride as a leaving group. We have pyridine in solution, and this pyridine is going to abstract the proton from this protonated alcohol, which will now give us our tosylate. This O-tosylate is, again, it's a good leaving group, and so it can leave in the following an SN2 reaction. The nice thing about tosylates is that you can isolate these, you can purify them, and use them now in a separate reaction. So the generalized way of thinking about this as well is you can write TSCl, and so the mechanism can have the alcohol react on the TS. In reality, it's reacting on the sulfur of the tosyl group, but this is a faster way of drawing it. And the pyridine abstracts the proton from this protonated alcohol species to give you your resulting ROTS. And again, this is called a tosylate group. So let's look at an example where we could use this synthetically. So if we had this starting alcohol, and we wanted to activate this starting alcohol to make it a good leaving group, we could turn it into a tosylate. And so again, the bond we've formed here is this between this oxygen and this tosyl group, so it's highlighted in purple. Alternatively, we can invert that stereocenter with phosphorus tribromide to give us this alkyl halide here. If we're now trying to do an elimination reaction on this particular compound, we can look at the protons that are anti-periplanar to the leaving group, because E2 mechanisms involve, again, anti-periplanar orientation. You can look at the mechanism for elimination reaction in a previous video. So I've highlighted these anti-periplanar hydrogen atoms as blue here. And so if we treat, so now again, in this case, this tosylate, the OTS, the whole thing is the leaving group. In this case, the bromide is the leaving group. So if we treat these with a strong non-nucleophilic base, in the case on the left, you're going to abstract this hydrogen here to give you now this alkene as the major product because it is more substituted. In this case, there is no anti-periplanar hydrogen that would give you the more stable alkene, so it's going to abstract this blue highlighted hydrogen atom here to give you now the less stable alkene as the only product. I'll also point out that you could have skipped these roundabout steps. If you wanted to make this major product from this particular alcohol, you could have simply used phosphorus oxychloride with pyridine, and you can look at a previous video about how to do that dehydration reaction. Thank you for your time, and I look forward to working with you on these interesting synthesis questions.